In this video, we are going to talk about the definite integral. So the definite integral has to do with the Riemann sum when we computed the limit as n approaches infinity of a Riemann sum, let's say I equals 1 to n of f of ci or f of xi, whatever you want to call that point. So ci delta x, this by definition is equal to, so this is equal to the integral. Now we're going to write numbers from a to b, provided that we are using the interval ab. So now we're going to write from a to b of f of x dx. So this is called the definite integral, because now we have this upper limit and lower limit. A here is the lower limit and b is the upper limit. So this is called the definite integral. Now, one thing that you have to notice about the definite integral is if we want to compute the definite integral for this function that I have in purple here, y equals f of x from a to b, what does it represent? This is what it represents. It represents this area here plus that area and this one. Now, when I say area, we have to be very careful, because when the region is above the x-axis, we compute the area and it has to be positive. We multiply by a positive sign because it's above the x-axis. And if you remember, when we were talking about the Riemann sum, f of ci, because the graph is above the x-axis, would be positive. So we compute this area and we multiply by a positive sign. For the next one, here we have that the curve is below the x-axis. So we're going to multiply whatever the area of that is by a negative sign, and here positive sign. So when the region is above the x-axis, you multiply by a positive sign. If it's below the x-axis, you multiply by a negative sign. So that's why they call the definite integral a signed area. So if you compute a definite integral, you get a negative number, it's perfectly normal. If you get a positive number, it's also perfectly normal. So a definite integral can be either positive or negative. It's not an absolute area, but a signed area. Now let's go over some properties of the definite integrals. The first one that I would like for you to know is the integral from, let's say, from a to b of a function multiplied by a constant k. So a to b, let's say we have k here, and f of x dx. So this is equal to, you can pull this k out, and the reason you can do that is because in the definition of the definite integral, you have the sigma notation. So the definite integral has the same properties as the sigma notation. So we can take this out and we're left with the integral from a to b of f of x dx. So that's one property that's very useful. And also we can break functions into two, or break definite integrals into two. So the second property would be, let's say you have f of x plus g of x dx. So you can break that into two. It's going to become from the integral from a to b of f of x dx plus the integral from a to b again of not f but g of x dx. And also another property that we should know is an integral from a to b of f of x dx equals, so we're gonna multiply by a negative sign, so it's equal to negative the integral from b to a. So if you flip this limit, make sure you multiply by a negative sign. So the integral from a to b of f of x dx is equal to negative the integral from b to a of f of x dx. And also a property that we're going to use a lot of times is when we have two adjacent intervals. Let's say we have a and b here, and somewhere in between we have c. It doesn't have to be in the middle. Let's say we have c here. Now the integral from a to b of f of x dx, so that means the integral from a to b of f of x dx is equal to the integral from a to c, the integral from a to c of f of x dx plus the integral from c to b, so from c to b of f of x dx. So we are going to use this property a lot of times. So these are the main properties of the definite integral. Another one that I can add, which is kind of obvious, is the integral from a to a. When you have the same number of f of x of any function, then you should get 0. The integral from a to a is equal to 0. And the very last thing that I want to add in these properties is the second property that we saw, meaning this one, also holds when we replace plus with minus. So if you replace this with a minus sign, then it holds. So you can erase this and have a minus sign as well.